All right, good morning, pre-calculus people. So if you're contemporary with this nice snowy day in Albuquerque, we did Texas yesterday, talking about they canceled virtual schools, and now I understand why, is that power was out everywhere, so that makes sense. So that was my bad for only reading the headline and not reading anything else after that. All right, so today we are going to take a look at more logarithmic equations, okay? So this one right here, this is 10 to the 4 plus 7r. So let's have a look at this. I'll put this up here and this down here so we can take a look at this. So drawing, so we have 10 to the 4 plus 7r plus 40. Okay, and that is equal to 92,000. That's it. Okay, so this problem type is pretty common. And the one pitfall you have is trying to take a log right away. Okay, because if you remember your rules of logarithms, we do not have a rule that lets us do anything with this. So if I take the log of this side and the log of that side, you think it might help, but there's nothing I can do with this because there's a plus inside of the logarithm, right? Just take, this is wrong. Okay, so this is all wrong here. We'll do it in this color. Okay, so this is definitely the wrong path. Okay, do not follow this path. So we can take the log of 10 to the 4 plus 7r plus 6,400, and that is equal to the log of 92,000. Okay, now because these are both not raised to an exponent, I can't pull this down in front. Okay, there's no times here. I can't break these apart in order to pull this down in front. I'm stuck. Okay, we're stuck right here. So don't do this. Okay, so this is a bad choice. Okay, it's actually, I haven't done anything wrong yet. I just kind of drove down a dead-end street and I'm just sitting there looking at it. Okay, so if I try to break this apart, that's something wrong. If I try to pull this down in front, because that's what we usually do, like there's a plus here, I can't pull them down in front for both of them. So at this point, I haven't done anything wrong, but I also haven't done anything like helpful. Okay, so this is not the way to go. Okay, so what we do have to do is we have to get all of the non-log stuff on one side. Okay, so what we are going to do is take our 10, 4 plus 7r plus 6,400 equals 92,000. Is it 6,400 or 64,000? 6,400. And what we're going to do here is we're going to subtract the 6,400 from both sides. Okay, that's what we're going to do first, because then we'll have our 10 to the 4 plus 7r by itself. Okay. And then what are we going to have over here? We're going to have 92,000 rather, minus 6,400. Okay. So I got an 85600 here. Okay. Now I'm going to go ahead and take the logarithm of this thing, and I'm not going to evaluate it. I'm just going to let it sit there. Okay. Now remember, you can't take the logarithm of a negative number. So if I screwed something up, like put a couple of extra zeros here by accident, or didn't put enough zeros here, and I got a negative value, I know I messed up. There'd be a solution. Okay. So now we have two clean kind of expressions on both sides. There's no pluses in the way here. What we're going to do is take the logarithm of both sides. Okay, and that is equal to the log 85,600. Okay, so now we're going to go ahead and apply rule 3. That's going to come down in front here. So we have 4 plus 7r times log 10, and that is equal to the log of 85,600. Okay. Now it's okay for my r to be, it's okay for the solution to be negative. But what actually I don't have to put it back in here. That's okay, because exponents, you could do a 3 to the negative 100, right? Or 3 to the negative 3. That's okay. That's just 1 over 27. Okay. So let's go ahead and subtract 4 from those sides. Subtract 4 from those sides. We have 7r. Oh, we said this before. We subtract the 4. What is the log base 10 of 10? Right? What could that possibly equal? Or 10 raised to what power is equal to 10? So this thing here, this log 10, that's just a 1. Okay, I kind of went forward assuming that this was a 1 when I subtracted off the 4. If it wasn't, I'd have to distribute. Okay. So I kind of jumped the gun there a little bit. Okay, so we have 7r is equal to log of 85,600 minus 4. Okay, if you want to put parentheses around that because you want to make sure that people know, or you know, that it's the log of 85,600 and then the 4 is a little bit separate, that's okay. And then what we're going to do is we're going to divide both sides by 7. So we're going to have r is equal to 1/7 log of 85,600 minus 4. Okay, and there's our answer for this thing. That does not look like an answer. Yeah, it does. We have r by itself. There we go. Now we might want to run in and say, well, what's r approximately? All right. And again, the rule going back from the 1950s, 70 years ago, is we go to 4 decimal places. Okay, that's what we do. So we're going to take, I have a calculator right here. So we're going to go ahead and take log of 85,600. Sorry, the calculators that I learned how to do everything on, you had to go backwards with everything. You had to do log of this minus that divided by a 7. So I'm still used to doing that. You guys can just type it in as you see it. That's fine. Okay, it all works. But we ended up with 0.1332. So, right, and that's our answer here. Okay. Now we'll go back to our book and we'll say, because the book is going to demand a different number of decimal places. And like, okay, whatever. It's just if I don't know, I'm going with 4 because that's just the way that. Oh, look at that. It's just 4 decimal places. Okay. So 4 is usually the standard. Okay. So what do we have here? We have the solution set is the exact value, right? This is going to be 1/7. Let's see if it lets me write that in. It did. All right, and then we have LOG, and okay, and then we have, we need, it doesn't let me do parentheses. Okay, this is 85,600. And then I'm going to need a minus 4/7 here, but you know what? I'm going to type in the negative 4/7 at the beginning because I don't have parentheses after the fact, and I have a feeling it's going to get mad at me if I try to do that. Actually, I have a feeling it's going to get mad at me regardless. So this was 0.1332. Okay, I know we have some medical people in our class, and they get really upset if you don't put that leading 0 in there. So I'm trying to be good-mannered and put that in there for us. And it's not going to like it. Your answer can be simplified. Let's see. What if I do this? What if I do this and I say, you know what, let's go with, I think that is simplified. I don't know what the heck they're doing. Okay, but this is 85,600. Right? And let's put a 7th root in here. I don't think that's simplified, but let's see. Oops, it's still, it's not gonna like that. I forgot to erase this. It was okay. Okay, that's fine. Okay, I wasn't really sure how they wanted me to write this thing, but there we go. All right. So the important thing to learn from this particular kind of example is we put these constants all on one side before we take a logarithm. Don't get bogged down on all the steps here. They'll follow themselves. But in order to set this thing up, right, in order to have a problem to solve to begin with, you got to take the 6400 and shove it over to the other side so you can actually work the problem. Okay. So let's go ahead and see what else we have here. Yeah, same problem. We can work this one. It's got an E in it. All of a sudden, that makes it harder, right? So we have 4e to the 2n minus 5 plus 3 is equal to 11. Same deal here, right? We want to take a logarithm. I would like to just take the logarithm of what's going on here. I want the 4 gone. I want this 3 gone. So we're going to subtract 3 from both sides. So we have 4e to the 2n minus 5, and that equals 8. Okay. Now, at this point, I can take the logarithm of both sides. I would not recommend it, and here's why. Okay, so again, I'll use this brown for, this is going to be the unhappy way of doing the problem. Okay, so we have 4e to the 2n minus 5 is equal to 8. Okay, so this is not negotiable. You have to get rid of this, okay, because there is nothing you can do with an ln of a plus b except look at it and say, that looks delightful. We're done. So nothing you can do with this. So we have to get rid of this 3. Now, if I take the natural log of both sides, why the natural log? Because e is, every time you see an e, it should be natural log. Right? Now again, this 4, right, what's the exponent on that 4? It's a 1. So I can't pull a 2n minus 5 out to the beginning because this exponent only has a 1. So what I have to do is I have to use my second rule of logarithm, my first rule of logarithm rather, and say this is ln 4 plus ln e to the 2n minus 5 is equal to ln 8. Now we're going to pull this off to the other side. And now we have ln of e to the 2n, it's a minus 5, I don't know why that switched. And then we have natural log of 8 minus natural log of 4. Now, and this, again, I haven't done anything wrong, okay? But I have noticed in the past that this step here is often forgotten because they get, students get really excited that they've done something correctly, and they want to pull this down to the side, and then it's not correct anymore, okay? Because they don't share the same exponents. Okay, so nothing is wrong here. It's just there's a lot more places for you to get lost along the way. This is ln of 8 over 4 because that's what the minus signs do. Again, a lot of places to start messing up here. It's the natural log of e, right? Natural log of e is equal to what? This is saying e to what power is equal to e. I think we could say that that's 1. Okay, natural log of e, that's 1. Log of 10, that's also 1. Okay, 10 raised to what power equals 10? E raised to what power equals e? Okay, so let's go ahead. At this point, it's the same on both sides. And we'll still get the right answer. All right. It's just that there's a little bit more peril on this pathway. Okay. Now, what I would recommend that you do, right, is divide both sides by 4 here. And then we have e to the 2n minus 5 is equal to 2. See, we still ended up in the same place here, right? Because I'm going to take a natural log of e to the 2n minus 5 is equal to the natural log of 2. Pull this guy down in front now, so we have 2n minus 1. ln e is equal to ln 2, but we know the ln e is 1. We have 2n minus 5 is equal to ln 2. Add 5 to both sides. So we'll end up with 2n is equal to 5 plus ln 2. Divide both sides by 2. we have n is equal to 5 plus ln2 all over 2. All right, and since they showed me in the last problem I was allowed to do this, I'm going to keep doing it. Let's see, do we want approximate? We need approximate. All right, so here's our calculator. We're going to say, right, 5 plus ln2. I'm going to go ahead and hit the equal sign because I don't want to mess up my division here. And then we'll take this number divided by 2. So 2 point, what did we end up with? 8466, 8466 here for round. Okay, and again, we went to 4 decimal place, so that's usually just the standard. Okay, so exact set, right? This was. So we have 5 plus, here's my natural log of 2, all divided by 2. Okay, my approximate was 2.8466. They're much happier about this now. All right. So again, this was the same problem as the last one. First thing you do, make it so that there's no pluses. Second thing you do, if there's any coefficient out of here, go ahead and divide by it before you take a logarithm. You really do. You want the cleanest thing possible to take a log of, but there's nothing we can do about this exponent, okay, until we've taken a logarithm. I think we did one like that yesterday. We did. Oh, this problem. I love this problem. Okay, so here we go. We have e to the 2t minus 4e to the t minus 12 is equal to 0. Okay, notice the 3 problems that we're doing today so far are these are all exponential equations. So if you're wondering, why didn't you check your answer? Because they're exponential equations, and the domain for exponential equations is all real numbers. It's the logarithmic ones. So when it starts off with a log in it, that's when you got to check. Okay, if it's starting off with something like this, you don't have to check first. Okay, so I'm going to make a little substitution here. I'm going to say, remember that e to the 2t, right? When you have two things multiplied by each other, this is e to the t squared, right? And you had a to the r to the s. This was equal to a to the rs, right? So e to the 2t is equal to e to the t squared. Okay, so I'm going to write this as e to the t squared minus 4e to the t minus 12 is equal to 0. Okay, so we're going to make a little substitution here because this looks kind of hard. Okay. Now, you don't have to make this substitution. Okay, I find a lot of students like making this substitution, but there are students that say this is an extra step and this is a waste of time for me. Like, okay, that's cool. You don't actually have to do this. And maybe by the 3rd or 4th time you've done this problem or a problem like it, you won't need the substitution anymore. But we're going to say let a equal e to the t. Now you can use whatever letter you want. You want a theta, you want an x, use whatever letter you like. Okay, we're going to have an a squared minus 4a, because that's e to the t, minus 12 equals 0. Now, I know you can solve this problem, right? This is an intermediate algebra problem, right? We got a factor, but we can do that. So this was a minus 6 and a plus 2, I believe. It's minus 6 plus 2 is minus 4, 0. Okay, so we're going to have a minus 6 equals 0, or a plus 2 equals 0. Again, zero factor principle. That's what this was, zero factor principle. Okay, that's the thing that we used. And then we have a is equal to 6, or a is equal to negative 2. Now it's time to say, well, what the heck was a? A was e to the t. So we have e to the t is equal to 6, or e to the t is equal to -2. What's the graph of e to the t look like? Humor me on this one. Okay, e to the t, oops, that's a terrible axis. Okay, e to the t looks something like this. Okay, here's my axis. Okay, here's my e to the t. This point here, that's 0, 1, by the way. Okay, does this graph go through y equals 6? Well, that's 6. Yeah, it connects. There's a solution here. Does this graph go through y equals -2 as a line? Should have used a different color. Right, does this pink line go through that green line? No, there's no solution here. Okay. If you try to take the natural log of both sides, you're going to end up with t is equal to the natural log of -2. And when I try to evaluate that, right, if you don't know, like, hey, you can't take the logarithm of a negative number. But if we try to do this, it's going to tell me domain error. Okay, non-real answer. Doesn't like it. So yes, this technically is a complex number. We are not going to worry about that just yet because that's actually, you won't worry about this in trig, although you do some stuff with complex numbers in trig. And Calc 1 and 2 does not have this. My Calc 3 class had like a last, like a intro to complex stuff like tacked on for the last 4 weeks. C&M does not do that. So you're going to have to wait to go to university and then take a class called complex analysis in order to get this. That's a 300 or 400 level class somewhere. Okay, at Tech it's a 400 level class. Okay. All right. So the only solution we have, right, is take the natural log of both sides. And then this is going to come down in front. So we have t times the natural log of e is equal to the natural log of 6. I know we've talked about the natural log of e a couple of times now. It's 1. So we just get t is equal to the natural log of 6. And that's your solution. Okay. Be careful about like just automatically discounting the negative one. That's not always the case. It often is, but don't just automatically assume, oh, it's negative, we're done. Like, no, if this was a, well, in this case, it's going to be, but I can imagine there's going to be times when it's not automatically going to work. So double check it. When you get to this point here, when you have e to the t equals -2, and you can tell by the graph or you can tell by this, then it's okay. But don't, as soon as we get to just this part right here, oh, it's negative, we're done. Like, no, not yet. Now you can make the decision. Okay. All right, this is one of my favorite problem types of this chapter, so make sure we practice this kind of problem, okay? Because I like to use this one, and it can get really awful. I try not to make them as awful as possible. Okay, there are more awful ways to do this. Actually, we will do one that's more awful, I think. Did they do it? No. Here, let me spring this on you. I used to do this to my college algebra class all the time. Okay, so just, we're never going to deal with this. Like, you never know. All right, if I use a previous college algebra test for you, you're kind of stuck. So if I do say an e to the x, okay, plus an e to the negative x is equal to, what does this graph look like? 4. All right. Well, you might look at this and say, well, we'll just do the same thing, or I'm just going to take the logarithm of both sides. Like, you can't take the log of both sides. Actually, you know what? We're gonna do it in that brown so that you know that this is a very wrong thing to do. Okay, this is not the right answer. So We have e to the x plus e to the negative x equals 4. And a lot of students do this. I said, well, they got the same base, so this is going to be x, and then we just got e. Do you see how much is wrong already? If you don't, you're not allowed to do this. Natural log does not distribute over plus. If you have the natural log of an a plus b, you're done. You got nothing. Okay, that's your answer. So at this point here, when you make this step, okay, that's a very sad day for you. Okay, it is kind of like doing this, right? It's kind of like, oh, I got the square root of a squared plus b squared. That's equal to a plus b, right? No, no. Every time people do this, right, it does. It kills me a little bit inside. But it'll kill you more because, you do this mistake. I'm like, no, we're just, even when you guys wrote it out, I'm like, that's just, you're at a 0. I'm not creating this mistake. This is almost as bad. You're at a 1 out of 10, okay, for making this mistake. All right. So you get a little bit of mercy because you just learned it, but not really. Okay, so you're not allowed to do that. So back to what you are allowed to do. Well, you can look at this e to the negative x and say, wait a minute, that's a fraction. That's e to the x plus 1 over e to the x is equal to 4. What do we do with fractions? Well, we clear them, right? Because who wants to keep the fraction around? So what we're going to do here is we're going to multiply everybody by e to the x, because that's going to clear that fraction. So here we'll have e to the x squared, or e to the 2x, plus 1 is equal to 4 e to the x. Then we're going to swing this e to the x to the other side. And we'll have e to the x squared minus 4 e to the x plus 1 equals 0. Pull the x to the other side. No. Because if I asked you this question, right, if I said let a equal e to the x, we'd have a squared minus 4a plus 1 is equal to 0. Now, here's the sad truth. Can you factor this? No, you can't factor this. So you have to say to yourself, like, if only there was some kind of a formula that helped me solve quadratics. Oh, there is, right? This one. 0 has to be on the right-hand side, okay? It only works if 0 is on the right. If it's not 0, you got to pull it over so you have the appropriate C here. Okay, so be careful about that. And then we can just go through and do this. So this is going to be negative 4 plus or minus the square root, right, of negative 4 squared minus 4ac. All divided by 2a. No, I know this is a little problem. I know. A is equal to 4, right? Because negative plus or minus. Now, if you type in your calculator and you're sitting there, okay, well, we've got negative 4 squared. And I ask you, before you do this, should this be a positive or negative number? And I hope you all said positive. But the calculator said it's negative. I really want to impress upon you that you really are smarter than your calculator. And you're going to make that positive. 4 times 1 times 1, 4. Yeah, all divided by 2. So this is 4 plus or minus square root of 16 minus 4 is 12 all over 2. And you're going to say, hey, wait a minute. 12 is 4 times 3. It's also 6 times 2, but 6 and 2 aren't perfect squares, whereas 4 is. So that's why the choice is with 4, because I'm trying to fish out any perfect squares in here. So this is 4 plus or minus the square root of 4, 2, root 3. 2. All right. Now we can divide by 2. Okay, now we could say a is equal to 2 plus or minus 3. Okay. This 2 cancel, right? It's half of it. Okay, so can we just get rid of the negative? No, afraid we can't. Check. It's positive, so we can't get rid of that. So we have e to the x is equal to 2 plus root 3. e to the x equals 2 minus root 3. So we're going to take natural logs of both sides. X is equal to ln of 2 minus root 3. See, that's why I said you can't just get rid of the negatives. You don't know. So this is going to be x is equal to natural log of 2 plus root 3, or x is equal to natural log of 2 minus root 3. Okay, and those are your two solutions to that problem. It's actually a very famous function, which is why I think it's important for you to be able to do this, especially if you're going into some kind of a mechanical or civil engineering, because this function, okay, this function is called a hyperbolic cosine. And it happens to be like if you have two poles and you've hung a chain between them, it's the shape of a, you might think like, well, hanging chain's a parabola, right? Like, no, if you have gravity, then it's actually a hyperbolic cosine. Okay, so if you're hanging wires, so even electrical engineering, if you're hanging wires, the shape that this chain makes, the shape that the wire makes, is this one right here. Okay, the length, you'll do this in Calc 2. The length of this thing is equal to something called the hyperbolic sine. Okay, the length of this chain is a hyperbolic sine. The shape of it is a hyperbolic cosine. Okay. Let me see one other neat thing about this. If you go to the arch in St. Louis, right, this thing, you see the arch in St. Louis? This is an upside down hyperbolic cosine. If you ever go here, there's going to be a plaque on the wall here, and it'll tell you what the equation is. So if you ever get to visit St. Louis, you'll now know a little bit more about the shape. It actually turns out that it's one of the more stable arches that you can build, which is why they chose that shape. Okay, kind of supports its own weight. So cosine height. All right, so that's the kind of problem that you get to see. Isn't that a good multiple choice question? Okay, this is a terrible multiple choice question. This is one of those I would definitely want you to kind of work out. But yeah, that's where this is going. Okay, we're not there yet. We're learning, but that is where this is going. All right, trying to stick with exponential functions for a bit. Does not seem to be. Oh, this is a good one. I've asked this question on the final before too. Okay. Actually, I've asked this one on a test and a final. So that's a good question. And the reason why is it hits all the places where students can make mistakes. So you gotta like that. Okay, I'm not going to use x's. I'm not going to use these rather. I'm just going to change them to x's. Okay. So we started off with a logarithm. That means that at the end, we're going to have to check our answer. Right? There's three classes of functions. There's three classes of equations, rather, that you have to check. Right? One of them is rational. Right? 1 over x stuff, because you have to check to make sure that the denominator, right, you didn't divide by 0 by accident. Radical, that's like square roots. Okay, so if you take the square root of a negative number, you know that ain't going to work. And logs. Okay. Technically, these are also the three conditions where you have to check your domains, right? If I ask you, like, hey, what's the domain? And you have a polynomial, right? That's a trick question. The domain is all the numbers. If I ask you to figure out what the domain is of an exponential, right? Like a 10 to the something or a 5 to the something, it's the domain for that. It's all real numbers. It's okay. But these three, if I ask you to check the domain, you got to make sure, like, is it 0? Is it bigger than 0? Is it bigger than 0? Okay. And if it isn't, or I should say, if you find numbers like that inside of your domain, like it ain't gonna work. So you have to remember to check this answer. Okay, this is equal to 3, I think, right? Yep. Okay, so we got to unlogify both sides. Okay. So which means we want one log on one side and at most one log on the other side. Okay. I don't want a number plus a logarithm or a number minus a logarithm. I want an expression with logs on one side, an expression with logs on the other side, or just regular numbers. Okay. So those are the choices. Okay. And again, there is a way around this. It's just this is the easy way to go. So you have a rule about logarithms that says that log of AB is equal to the log of A plus the log of B. I can pull these, this equation works in that direction too. So what we're going to do here is we're going to say this is the log base 3 of x plus 6 is equal to 3. Allow me one moment to keep going for just a minute because I don't want to lose this. All right, now we're at the stop. We can take the anti-log. Okay, so what we're going to do is we're going to make each side of the equation, we're going to make it the exponent to a base of 3. Well, why 3? Because it's log base 3. Okay, if this was log base 17, then this would be 17. Okay, if it's log base 5, this is going to be 5. But since it's 3, we're going to make this 3. Okay, so we have to remember b to the log b of whatever is equal to that whatever. So this side's easy. This side is just x squared plus 6x. Now you see why I multiplied through is so that I didn't have to worry about what was going to happen. Now, you have to be careful here. What's 3 raised to the 3rd power? It ain't 9. 3 times 3 times 3 is 27. Okay. So we're going to bring this over to the side and say x squared plus 6x minus 27 is equal to 0. And I think we're going to have x plus 9, x minus 3, right? That's going to be 3x minus, or 9x minus 3x is 6. Negative 27, we're good. So x plus 9 equals 0, x minus 3 equals 0, x equals negative 9, x equals 3. And then, are we done? No, we have to check. So if I take negative 9, put it, you have to go back to the original. Okay? You always go back to the original. Think of Christmas Carol. Right, and that first ghost that Scrooge meets those business partners carrying around all those heavy chests. You have to go back to the beginning. You have to go back to your heavy chest and test it. Now, here's why I tell you, you don't have to write them out, because you could look at this and say, oh, it's log of negative 9. This ain't gonna work. Okay, by inspection. If you ever want to, by inspection. You ever want to tell a teacher, or somebody you're doing a test and like, this was too easy. By inspection. Okay. And then this one you can write it on, okay, but don't write that all the time. Okay. 6 or x equals 3, put it here, they're both positive. This one checks out. So if we checked, my solution set, right, is just this one. Okay. That's what I said. You don't have to show it in numbers. If you rate, I checked, I will believe you that you checked. Okay. So my solution set is S is equal to 3. All right. And the exact solution set is 3. They didn't give me a thing. I wonder if they're gonna. No, they want solution set. So let's go ahead and make it a set. Otherwise, I'll be upset. By the way, I don't. When I did this by hand, I never cared to put the little brackets in there because I never heard the right. And just say, x. The answer is x equals 3. I'm like, that's fine. I'm not gonna care. All right. So that's that's a I have chosen this problem for tests. I've chosen this problem for finals. It's a really good problem because it has, right? It has, did you know how to do this? Did you know how to put the two of them together? Did you know that 3 to the third is 27? Okay. Did you know to check because it has one answer that isn't? It's got all the pieces in there to make that a really good problem. Okay. It's hard to find problems like this though. If I say try another, I'll bet they'll give you the same thing. Okay, nearly, but maybe we'll save one like that for tomorrow. Okay. I've used this one on an exam too. Okay. So this one, there's a couple of ways we could do it. So this is log base 4, 5w minus 8 is equal to 1 plus log 4, and this was w plus 2. All right, so again, what we want to do is we want to make sure that there is at most one logarithm on either side. So we could either have a log or a whole log over here, or we could have logs over here, like one log over here, and just numbers over here. Okay. So again, let me show you the wrong way to do this. Well, it's not wrong. It's just a little bit more involved. I would not expect students to pick this one up. Okay, so this is going to be log 4, 5w minus 8. Now, if you want to take on logify, just do 4 immediately, we have to deal with an exponent here. So what I'm going to do instead is I'm going to say, well, log base 4 of 4 is equal to 1, isn't it? Right? 4 raised to what power is equal to 4? So here we have log base 4 of 4 plus, this is equals log base 4 of w plus 2. All right. So this is log base 4 of 5w minus 8. Now we got a plus here. This is log base 4 of 4w plus 8. Is it okay if I multiplied those through like that? Okay. Now we can unlogify. Okay. Now we're going to make both sides, the exponent to a base of 4. Why 4? Because that's 4. Okay. You have to have the same base. Again, I only know of one equation that uses 2 different bases. That uses both base 10 and base e. And it drives me nuts that they did that. And it's a formula from hydrology. And to this, I can't remember the formula, but it's one of those things where this guy, that was a terrible idea. Whoever did that, that was awful. All right, so let's go ahead and add 8. So we have, and we're going to subtract 4w at the same time, minus 4w. And we get 5w minus 4w is w is equal to 16. Now, we started off with a logarithmic equation. We're going to check it out. If I plug in 16 here, oh, they're both positive. Check, check, we're okay. How should a student, how would I expect a student to do this one? Okay. What I would expect you to do, all right, is to pull one of the logs to the other side. W minus 8 minus log base 4 w plus 2 is equal to 1. Okay, so all I did is I pulled the log over here, I pushed it over here instead. Okay, now we're going to have log base 4, we're going to have 5w minus 8 over w plus 2, right? Because you have a rule that says the log of a over b is equal to the log of a minus the log of b. And again, it works in both directions. All right, now we're going to unlogify both sides. We're going to make both sides the exponent to a base of 4. So we're just going to have 5w minus 8 over w plus 2. that equals 4. So when we clear the fraction, you'll notice that we're very much in the same situation as we were right here. Okay, so you end up in the same spot. Okay, provided you did all the steps correct, you do end up in. So I can't tell you like the first way was wrong. I'm just going to tell you that the first way was there's mistakes that students make. Okay, there's mistakes that students make. So just to be careful about how you're doing this, but I think you can solve it from there. Okay, so just be careful about how you're solving it, but you're going to be okay. Right? There's multiple ways, and as long as you don't do something illegal with it, like using property incorrectly, it'll all work out regardless of how you did it. All right, but just want you to be real careful about choosing your path, because some paths are easier than others. Okay, so I think I'm going to go ahead and stop there, and we will pick up doing some more of these tomorrow. So I'm going to go ahead and stop recording. Wish everybody a good day.